Question number 23, Singleton design patterns, implementation, example, double check locking. Singleton is a part of gang of 4 design pattern and it is categorized under creational design pattern. In Java, Singleton design pattern will ensure that there is only one instance of class is created in the Java virtual machine. It is used to provide global point of access to the object. In terms of practical use, Singleton patterns are used in logging, caches, thread pools, configuration settings, device driver objects. Design pattern is often used in conjunction with factory design pattern. This pattern is also used in service locator JEE pattern. Structure of design pattern consists of static member. This contains the instance of Singleton class. Private constructor. This will prevent anybody else to instantiate the Singleton class. Static public method. This provides the global point of access to the Singleton object and returns the instance to the client calling class. Implementation example, lazy initialization. Let's look into the Singleton implementation example in Java. The below code uses lazy initialization process. The example has Singleton example class which has a static variable Singleton instance of type Singleton example which is private static variable. Singleton, then private constructor is there Singleton example. Below that there is a static method for providing the global point of access. Then there is a print Singleton method. In that we have printed the inside print Singleton statement. Singleton pattern code explanation. When this class will be called from the client side using Singleton example.getSingletonInstance.print Singleton method, then at the first time only an instance will be created. During second time onwards, for all subsequent calls, we will be referring to the same object and the Singleton instance method returns the same instance of the Singleton example class which was created during the first time. You can test this by adding a print statement the following code as. See the following code here. We have just added the statement system.out.println in bracket creating new instance in get Singleton instance method, static method. If we now call Singleton class from the client class as below code, then we have the output as you can see here. Creating new instance is one time printed and the remaining time it is printed inside print Singleton. Implementation example, double check locking. The above code works absolutely fine in single threaded environment and process the result faster because of lazy initialization. However, the above code might create some abrupt behavior in the result in multi-threaded environment, as in this situation multiple thread can possibly create multiple instances of the same Singleton example class if they try to access get Singleton instance method at the same time. Imagine a practical scenario where we have to create a log file and update it or while using shared resource like printer. To prevent this, we must use some locking mechanism so that the second thread cannot use this get instance method until the first thread has completed the process. Singleton in heap. Multiple threads can access the Singleton instance since the Singleton instance is static class variable in the stored in per gene space of the heap. This applies to instance method instance as well as since it is static too. In the multi-threading environment, to prevent each thread to create another instance of the Singleton object and thus creating concurrency issue, we will need to use locking mechanism. This can be achieved by synchronized keyword. By using this synchronized keyword, we prevent thread 2 or thread 3 to access Singleton instance while thread 1 inside the method get Singleton instance method. From the code perspective, it means you can see here we have declared the synchronize method and we have used the synchronize keyword for this. So this means that every time get Singleton instance is called, it gives us an additional overhead. To prevent this expensive operation, we will use double check locking so that the synchronization happens only during the first call and we limit this expensive operation to happen only once. It is only required for the Singleton instance equals to new Singleton example. So code example is given here. You can see here the public static volatile Singleton example. In that we have used the synchronize block. We have used the Singleton example.class and after that null instance we are checking here. In the above code snippet, imagine that multiple threads concurrently and tries to create the new instance. In such situation, maybe 3 or more threads are waiting on synchronized block to get the access. Since we have used synchronized block, only one thread will be given access. All the remaining threads which were waiting on synchronized block will be given access when first thread exits this block. However, when remaining concurrent threads enter the synchronized block, they are prevented to enter further due to the double check, null check. Since the first thread has already created an instance, no other thread will enter this loop. All the remaining threads that were not lucky to enter the synchronized block along with the first thread will be blocked at the first null check. This mechanism is called double check locking, and it provides significant performance benefit, and also it is cost effective solution. Implementation example: volatile keyword. We can also use volatile keyword to the instance variable declaration. For example, private volatile static singleton example singleton instance semicolon. The volatile keyword helps us concurrency control tool in multi-threaded environment and provides the latest update in most accurate manner. However, please note that double check locking might not work before Java 5. In such a situation, we can use early loading mechanism. If you remember about the original sample code, we had used lazy loading. In case of early loading, we will instantiate the singleton instance class at the start, and this will be referred to the private static instance field. The code has given here. You can see that here private static final singleton example singleton instance equals to new singleton example. The object has been created at the start here. In this approach, the singleton object is created before it is needed. The JVM takes care of the static variable initialization and ensures that the process is thread safe and that the instance is created before the thread tries to access it. In case of lazy loading, the singleton instance is created when the client class calls the get singleton instance, whereas in case of the early loading, the singleton instance is created when the class is loaded in the memory. Implementation example using enum. Implementing singleton in Java 5 or above version using enum. Enum is thread safe, and implementation of singleton through enum ensure that your singleton will have only one instance even in multi-threaded environment. Let's see a simple implementation. You can see the code here: public enum singleton enum. In that we have created one instance semicolon variable and one doStop method to print the singleton using enum statement, and below that you can call the client using this code singleton enum dot instance dot doStop. Let's see some questions related to singleton. Question 1. Why can't we use static class instead of singleton? The answer is, one of the key advantages of singleton over the static class is that it can implement the interface and extend classes, while the static class cannot. It can extend classes, but it does not inherit their instance members. If we consider static class, it can only be a nested static class, as top level class cannot be a static class. Static means that it belongs to a class it is in and not to any instance, so it cannot be a top level class. Another difference is static class will have all its member as static only, unlike singleton. Another difference or another advantage of singleton is that it can be lazily loaded, whereas static will be initialized whenever it is first loaded. Singleton object stores in heap, but static object stores in stack. We can clone the object of singleton, but we cannot clone the static of class object. Singleton can use the object-oriented feature of polymorphism, but the static class cannot. Next question: can the singleton class be subclass? The answer is, frankly speaking, singleton is just a design pattern and it can be subclass. However, it is worth to understand the logic or requirement behind the subclassing a singleton class, as the child class might not inherit the singleton pattern objective by extending the singleton class. However, the subclassing can be prevented by using final keyword in the class declaration. Next question: can there be multiple instances of singleton using cloning? Answer is, that was a good catch. What do we do now? To prevent the another instance to be created of the singleton instance, we can throw exception from inside the clone method. Next question: what is the impact if we are creating another instance of singleton using serialization and deserialization? Answer is, when we serialize a class and deserialize it, then it creates another instance of the singleton class. Basically, as many times as you deserialize the singleton instance, it will create multiple instances. Well, in this case, the best way is to make the singleton as enum. In that way, the underlying Java implementation takes care of all the details. If this is not possible, then we will need to override the read object method to return the same singleton instance. Next question: which other pattern works with singleton? There are several other patterns like factory method, builder, and prototype pattern which uses singleton pattern during the implementation. Next question: which classes in JDK uses singleton pattern? Answer is, Java.lang.runtime. In every Java application, there is only one runtime instance that allows the application to interface with environment it is running. The get runtime is equivalent to the get instance method of the singleton class. Uses of singleton design pattern. Various uses of singleton design patterns are there. First is hardware interface access. The use of singleton depends on the requirement. However, practically singleton can be used in case external hardware resource usage limitation required. That is, hardware printers where the print spooler can be made a singleton to avoid multiple concurrent access and creating deadlock. Second, logger. Similarly, singleton is a good potential candidate for using in the log file generation. Imagine an application where the logging utility has to produce one log file based on the messages received from the user. If there is multiple client application using this or logging utility class, they might create multiple instances of this class, and it can potentially cause issues during the concurrent access to the same logger. We can use logger utility class as a singleton and provide a global print of reference. Third, configuration file. This is another potential candidate for singleton pattern because this has performance benefit as it prevents multiple users to repeatedly access and read the configuration file or properties file. It creates a singleton instance of the configuration file which can be accessed by multiple calls concurrently, as it will provide static config data loaded into the memory objects. The application only reads from the configuration file at the first time and thereafter from second calls onward the client applications read the data from in-memory objects. Fourth is cache. We can use the cache as a singleton object as it can have global point of reference, and for all future calls to the cache object the client application will use in-memory object. Question number 24. What is the difference between static block and singleton block? Singleton object stores in heap but static object stores in stack. Second, we can clone the object of singleton but we cannot clone the static class object. Third, singleton class follow the OOP object oriented principle but not static class. Fourth, we can implement interface with singleton class but not with the static class. Static classes should not do anything need state. It is useful for putting bunch of functions together, that is math or utils in project. So the class name just gives us a clue where we can find the functions and there nothing more. It's more flexible than static class and can maintain state. It can implement interfaces, inherit from other classes and allow inheritance. Question number 25. Can you override static methods in Java? No, you cannot override static methods in Java. Static method belongs to the class level, not at object level. You can create a static method with the same name in the child class and it won't give you compilation error, but it is called method hiding, not method overriding. You won't get overriding behavior with it. Question number 26. What is the design pattern? How will write singleton to get the deserialized singleton object? What read resolve method? If you want to implement serializable singleton, you should additionally add read resolve method. Sometimes in distributed system, we need to implement serializable interface in singleton class so that we can store its state in file system and retrieve it at later point of time. Here is a small singleton class that implements serializable interface. The problem with above serialized singleton class is that whenever we deserialize it, it will create a new instance of the class. So it destroys the singleton pattern. To overcome this scenario, all we need to do it provides the implementation of read resolve method. After this, you will notice that hash code of both the instances are same in the test program. So code has given here. You can see the protected object read resolve in that need to return the get instance method. That's it.